My name is Matej, and today I will, well, at least try to take you over some steps on how to achieve good signal quality during EMG acquisition. During my presentation, I will use some signals recorded with Quattrocento. Signals that I will show to you are intentionally from the screenshots. Okay? So I used screenshots from OTB software intentionally because we always do a quality check during some live feed. Okay? We don't record signals in advance and then analyze them for noise. We do it on a fly. Okay? And that's why I use screenshots. In some pictures we'll have maybe have a bit of problem identifying noise, but I think it will be okay. So used Quattrocento for acquisition. Acquisition of all signals was done from battery. I used 64 channel electrode on TBIs anterior. Patient reference and pre-amplifier references were on the ankle with these reference straps. Okay? Monopolar type of acquisition and standard bandpass filtering between 10 to 500 Hertz. Some motivation. Here we have 64 channel electrode. At the beginning, we can see flat lines. There we can observe, at that point we can observe relaxed muscle. Okay? At that point, at the beginning, there is no activation, relaxed muscle. All EMG signals are perfectly flat. No noise, no activity. After 2 to 3 seconds, we get into the mild muscle activation, about 10% MSC. We see normal EMG signals, and after about 5 seconds, follows by relaxation again. Okay? So these kind of signals, these flat lines, should be somehow our baseline to pursue. Okay? This is what we would like to see when doing EMG acquisition. Okay? Before participant comes to the measurement, it's quite wise to give them some instructions. Most importantly, maybe they should shave the area where we will place our electrode. They should not use any shaving foams or something like that. Instruct them not to use any cosmetic products on the place or on the area where the electrode will be placed. These cosmetic products can actually act as a thin, non-conductive layer, which can cause some strange noise to happen, or even flat EMGs. Okay? So, 2 very important instructions. The last one, don't drink coffee. Coffee affects us very differently, but it can affect firing frequency of motor units. Okay? So, instructions before participant even comes to us. When the participant is at our measurement, we should pay attention to a few steps. The most important one, try isolate participant as much as possible. Okay? Isolate in a manner that you see them on, I don't know, some rubber mattress, some chair with some rubber isolation. Try preventing contact between participant and the metal. Okay? This will cause you to have a lot of line interference. So prevent contact with metal if possible. It's not always, okay? But if possible, do it. Next step can be a bit tricky. Identify possible noise sources. I've listed them a few. like air-conditioned fluorescent lamps, refrigerators even. Why this can be tricky? Because these devices are not always on. Okay? AC does not run all the time. You can make a setup, place an electrode, signals are totally fine, perfect, and after 10 minutes in time during recording, you get some strange noise, and you cannot explain it why. Remember, AC, fluorescent lamps, refrigerators, everything, every device that runs in the same place where you are taking measurements can affect your signal quality. MRI device is very tricky. I have a story a few years ago. We were doing some measurements in hospital. We had some noise I could not explain. It was around 400 hertz. I could not explain it. Where did it come from? How to eliminate it? We tried everything. Okay? After 3 days into measurements, we were told that there is an MRI machine 1 floor lower. Okay? And that was the case. It was quite funny that noise was always gone after around 4 p.m. Why? Because doctors stopped working at that time. Okay? Turned the MRI machine off. It was not in use anymore, and the noise was actually gone. And that is some tricky type of noise to even identify if you don't know what else is in the same building where you're taking measurements. We at our faculty have problems with electrical department. They have some simulated, how's it called? Some big electrical motors there, I don't know, 100, 150 kilowatts, and they produce noise all over the faculty. Okay? We have quite a big problem with that. The last thing, what you can do or should do is try powering all devices from the same socket. Usually these sockets on the wall are power balanced, okay? So they don't have the same power phase. And if you put two devices used in the measurement protocol in the different power phase, you will get interface voltage noise, okay? I'm not saying that you will, but you can, okay? So remember this can be sometimes tricky. It looks like a power line interference, okay? But you don't know where is it from. Remember, try powering everything from the same phase. Just use extension cord and put everything into the same cable, okay? This is a picture of one of our rigs we are using. I've intentionally marked all the areas where the participant can come into the contact with metal. All these parts are somehow isolated with rubber, some other plastic materials. It has even plastic legs. One trick here, if you use chair, ordinary chair, put participant on the chair, maybe even without its shoes. So he has like maybe barefoot or with the socks on the floor. You can get very high power line interference, okay? Try isolating the chair used, okay? And that's why these devices or these rigs have plastic legs to act as some kind of insulator and prevent power line interference, okay? Well, next step, skin preparation. Very important step. Skin preparation and electrode preparation are the most important steps here. Noises coming from those two steps can be very easily interchanged between, and we have to be sure we've done it correctly, okay? First thing, shave the skin. Shaving the skin won't only remove hair and improve electrode adhesion, but hair can as well cause inter-electrode contact. like a short circuit on the electrode surface. Next thing, clean the target area with abrasive gel for better conductance. This will somehow remove the dead skin cells and other impurities from skin. If possible, don't use alcohol anytime. If possible. The next line is kind of opposite of what I'm talking right now. So, if possible, don't use it because it can dry up the skin. Dry skin, bad conductance. Okay? Be careful with the amount of pressure applied when scrubbing. Scrubbing with this abrasive gel, it's not what you wish to do every day. Okay? If you have participants with some kind of skin troubles, like maybe psoriasis, this can be a problem. You don't want skin to become too reddish, even worse in psoriasis. So if the participant has psoriasis, you can even make skin bleed a bit. You don't want it. Okay, so be careful with the amount of pressure applied. The last thing is kind of opposite of what I said before. So if the participant did not follow your instruction in a manner of not using cosmetic products, you have to use something more aggressive than only abrasive gel. Okay? These cosmetic products can be quite problematic, especially sun cream. Okay? Sun cream kind of preparates the skin and you have to really clean it. Okay? And that's when I would advise using isopropyl alcohol. Why? Because it dissolves Vaseline. Okay? Vaseline is quite a common compound of these creams, pastes, whatever. It dissolves it quite nicely and you can do very good skin cleaning. And the last one, we learned that last year. We had a lot of noise after ultrasound was used on the same place where we put the electrode afterward. And the ultrasound gel was actually the cause. Okay? You cannot clean ultrasound gel, or maybe sometimes you can, only with abrasive gel. So you want to have something more, under quotes, aggressive to get it off the skin. Okay, next thing, electrode preparation. First, very important step, we commonly just skip, inspect the electrode for oxidation. I have a picture of one of electrodes. Can you see here in the middle? How did I achieve this? I left electrode on the open air, uncleaned, for 1 week. After 1 week, I cleaned it, and this happened. Do you see oxidation? So this discoloring here in the middle is oxidation. This will cause some weird noise in our EMG signals, and we will not be able to take it out. Okay, so what can you do here? Try cleaning it, or throw it in the bin. Take a new one. Just a practical advice, don't bother using them because you will have hard time trying to clean this oxidation off. Okay, next thing, carefully align and apply adhesive foam. So I have here, I think that you're all familiar with this. I have some electrode adhesive foam, align it, apply it, and the next important thing here is firmly press the foam onto the electrode. In my case, I'm using OTB's electrodes and OTB's foams. In the, I don't know, 4 years ago, these foams had very mild adhesive, okay? They came off very easily. These new foams are a lot better. They have very strong adhesive, and this is more of a just precaution. It's kind of hard to push the paste underneath the foam, okay? Because of this strong adhesion. So if paste gets underneath the foam, it can cause inter-electrode contact. So put it on, strongly push it onto the electrode, and then paste the electrode. What do I mean pasting the electrode? So after the adhesion, we have this hard plastic spatulas. Just paste the cream or the paste onto the electrode. What can happen in hot environments? These creams or paste can get more liquidy. Okay? When they get more liquidy, they tend to go underneath the foam. So don't apply as much pressure, okay? I tried doing this last week because this usually happens in the hot summer. I tried this last week and yes, it did happen. I have a photo of it, so careful about it. Another one is more of a question to you. We always use conductive paste. Is anybody experienced in using conductive gel? I know that some groups use conductive gel. I have two questions here. What will happen to gel after 1 or 2 hours into the use? I know the answer to that. Gel will harden, okay? It is quite the same gel used for EEG, okay? If you have EEG recordings like 2-3 hours long, the gel will actually harden up, and the same will happen here. To the last one, I don't have answer. What will happen to gel in hot environment? Okay, gel is kind of viscous. If you heat it up, it becomes like water. Okay, what happens to gel inside the paste, inside the foam on the electrode, when is in contact with the temperature of human skin for 2-3 hours? What do we get? I don't know, I never tried it. We don't use this, so maybe somebody else would be better to question this. Okay, so the process of making electrode, what should it not look like? Okay, at least the last image, we have a problem there. Pasting the electrode with this plastic spatula, we get pasted electrode, and removing the last protective layer pulls the paste out of the hose. Okay, this is what we don't want. Of course, we can fix it, put it back, repaste it, try removing it again. Usually it works. If not, remove everything, clean the electrode, new foam, repaste again. Okay. If you take a look at the middle picture, you see that I intentionally left very thin film of paste on top, on the last layer. Okay? Why do I do that? Take a look at this picture. After removing the last protective layer, we have kind of extended paste over the foam. And when we will apply this electrode to the skin, this paste will push back into the holes, okay, and make good contact. Be careful on how much paste do you leave on the last layer. Why? If you leave it too much, if these extensions, let me say, will be too high, when you push it against the skin, they will make intercontact with its neighbors. Okay, so I cannot say how much. It's not a millimeter. Okay, it's less. Just leave it a bit on, because if you scrub it hardly down, you actually get holes, and that's what you don't want, because the holes in the holes will produce bad contact. Okay, the holes will be filled sufficient. Here we have an example. What happened here is, I mentioned it before, hot cream, hot paste, hardly pushed into the holes. The adhesive was not good enough. Was not good enough because I did not clean the electrode after the previous use. Okay, I intentionally left very thin film of paste on the electrode, just stick the adhesive foam on. Adhesive, of course, did not stick well, and the paste got underneath. And this is how it looks. After removing foam, you can clearly see that there's inter-electrode contact. It's quite hard to see this in monopolar type of recording, okay? You can see it in differential mode because it will usually produce flat lines, but in monopolar, it's hard, okay? All the, I don't know, 3-4 electrodes will have same signal, but you cannot determine if that's okay or it's inter-electrode contact. So, it can be difficult. Watch about this. After the placing the electrode to the skin, firmly fix it. My advice is not to use micropore or other medical tape-like products, just because using them does not guarantee you uniform pressure all over the whole electrode. What we do, we use these elastic straps, place them around the electrode, around leg, around the arm, if possible. If it's not possible, I don't know, maybe on the FDI muscle, you cannot use this, okay? You have to use some other products, but if possible, use white elastic bands. They will produce more uniform pressure to the electrode, okay? Here is how it looks like. So, on the left side, attached electrode, and on the right side, we have fixed the electrode with elastic bands. Okay, so this electrode is on the tibialis anterior. And the last thing we have to do is put on a reference. If possible, again, if possible, not always is, I would recommend using these reference strips soaked into the water because they tend to work a lot better on dry skin. Okay? Winter months, dry skin, using ordinary reference electrode, adhesive reference electrodes like this one, can have problem. If you have to use it, one advice, put a bit of conductive paste or gel on the other side. Okay? Take it off, put a bit of gel on, and then stick it to the skin. Okay? This will produce a lot better skin conductance. Okay? You can even try scrubbing the area of this where you intend to place the electrode with a bit of abrasive gel and then put the electrode on. Okay? So remember, these adhesive electrodes can be tricky. Okay? Don't just place them on and that's it. I'll show you later what happens if you do that. Okay. These are the two reference straps used on the ankle. Watch about interspace between them. Why? One is used for patient reference, one is used for preamplifier reference. Why can we have problem if they are in contact? Patient reference works as a negative input to Quattrocento. Positive input comes from electrodes. And if they are on the same potential, we cannot sufficiently filter out line interference. Okay? So that's why they have to be separated. They have to be on muscle inactive areas. Okay? If you have to put them somewhere. We usually look for a bone, for a place where there is minimum option of being, of having some muscle activity. Okay, we've done everything, but we have noisy signals. Okay, we have flats, maybe. Now we'll take a look at some edge cases, what can happen, and how to try to solve that. It's not always possible, okay? This is kind of disclaimer. So, not always possible to solve, but there always is a solution, okay? The solution is participant go home, That's the easiest. Okay. It actually happened once. We could not make measurement of one participant. I and Milos back there did some measurements on the medical faculty, and we could not make it work, and actually had to tell the participant, go home, you're not any use to us, just because of the noise. We could not identify where did it come from. Okay, first example. You can believe it on my word that this is 100 or nearly 100% MAC. We have all flats. What happened here? What I did is I perfectly prepared the electrode, at least in my opinion, okay, and just place it on the skin. No shaving and no skin scrubbing. And this is what we get. 2 little bumps, and that's it. Nothing. Always, remember, always clean the skin, shave the skin if you want signal quality to be okay. Next one, the most cases, in most cases, we get something like that. This. It's hard to tell in these situations if there is a skin cleaning problem or an electrode preparation problem. Okay. In this case, it is electrode problem. How can we identify it? Noise is not uniform over all electrodes. Some electrodes are flat, which is perfect because we are looking at the relaxed state. So no muscle activity. What we want to see here is all lines to be perfectly straight, so all flats, but we have some noisy electrodes. The next one, the same electrode as before, just that now we have mild muscle activity, about 10%. What do we see? All the electrodes that were noisy in a step back are now showing normal EMG activity. Of course, signal or noise is still present, it's just blurred in. Okay, so don't get deceived by this. And we have 4 kind of flat signals, which means that we don't have contact with skin at all. Okay, so what do? A bit later. In the next example, what I did is perfectly clean the skin, perfectly prepared new electrode, put it on, and just loosened the reference a bit. So I used this reference strap and just loosened it a bit, so it was not tight around my ankle. What can we observe is that power line interference is starting to gain in its amplitude. Okay? When can this happen? This is quite common to happen. If you put the strap around the ankle too much, too lower, and you hit tendon here behind. Okay? When the participant will make move, will activate muscle, whatever move, dorsiplantar flexion doesn't mean, and the tendon kind of bulks out, okay? Becomes bulky, the strap can actually loosen itself, okay? So careful about it, because this usually happens when we are measuring EMG, not in rest state, okay, but in active state. Watch it, can happen, happens a lot, okay? Next thing, all electrodes have a high amplitude, 50 Hertz present. This is because patient reference and pre-amplifier reference are in contact. So what I did is just put the 2 references on the ankle together, and I got high 50 Hertz line interference noise. Why is it present? I talked about it a few slides ago. Careful about this. This happens usually with smaller people. Why? Because we don't have enough space from ankle up to the soleus muscle. We put those straps too much together, so the interspace is not as big as we would wish to be. And during the time, these 2 straps just touch, okay? Careful about that. If you have smaller people on your measurement, use one strap and one adhesive electrode if possible, okay? You can put the adhesive electrode on the ankle, you can put it on tibia bone, wherever. Just careful about this, that two straps don't come into the contact.
You can always put the patient reference on the other side.
I have a slide a bit later. What do we get if we put patient reference on the other side of the heart, let me say so. Okay, opposite limb. What do we get? We get ECG, okay, because we crossed the heart, okay. I actually tried measuring that. Me and Nina did, and I could not make QRS complex high enough in amplitude to be seen. Okay, what we did is Nina held her breath for a few minutes until she was blue-skinned, okay, and did not help. Okay, I tried the same next day and did not help. I told my colleague Uroš, I don't see my ECG, and he said you should visit the doctor. Okay, if you don't see your ECG, there must be something wrong with you. Okay, so we'll come later to that. Now the sample where I've used, so skin is perfectly prepared, electrode is perfectly prepared. Just what I did here, I just replaced the strap reference, okay, this one, with some ECG electrode, ordinary ECG electrode that, I don't know, 20 mils, and this is what we have, okay, nothing. Reference was put on the tibia bone, here on the top, okay, it's nothing. What I tried then, I scrubbed the skin beneath where the electrode was placed and replaced the same electrode on the same spot. It's better, but we still have a lot of noise, okay? Why is that? Any ideas? I have this question in quiz, okay? Just remember, electrode size has something to do with this, okay? It's actually written in one of your literatures I provided, so tricky one. And next what I did, placed the reference electrode, bigger reference electrode, on the same spot, no additional cleaning, just replace them, put it on, and we have nearly perfect signal, okay? We can observe that one channel is a bit noisy, and in 2 time moments there we have small bumps, but that is more likely some very mild muscle activity, not the noise, okay? Next one, line interference, 50 Hertz all over. What I did here is just touch Quattrocento's power supply cable. Just touched it, okay? And this is what we have. Next one, movement artifact. What we did here is we did not fix the electrode to the skin, no, not with the elastic band or any other tape, and just tried moving it, okay? Just tried moving it with very short moves on the skin. So actually the electrode moved on the skin, okay? And that's why what we get is this very low noise, very low frequency noise. The point of this is fix the electrode, firmly fix the electrode to the skin. Okay. The next one is kind of edgy. Participant can't relax. This is quite common. You see, or you can identify it by looking at the signals that they have kind of small activity, almost evenly spaced in time. Okay, this can happen, and happens quite a lot. What can you do here? Not much. You can encourage participants to try to focus and relax. This usually helps just for a short period of time, and then it's back to the old tracks. Okay, you have some activity and the participant cannot relax. There's no way he or she will relax on the whole measurement. Okay, what do we have here? Any ideas? Take a look at the top electrodes. We have some 50 Hertz noise. All other electrodes are noisy. Any ideas how this could happen? What I did here is I replaced 2 electrodes, 2 cables, 1 adapter, and still the noise was present. Cleaned skin 2 times, okay? What it was, when I was placing quadricental on the table, the connectors, auxiliary connectors at the back, touched power cable of the adapter, okay? This was solved in 15 minutes. Just unintentional thing. I heard and did this bad thing, okay? Look at your equipment, how is it powered? If all the cables that should be as where they should, so nothing touches anything that it should not. Okay. Some other possible noises, I explained it already. So you can get ECG into the EMG by putting a reference on the opposite side or on the opposite limb, so that you cross the heart. But of course, it is not impossible to solve or impossible to filter it out, okay? If you have some normal ECG, it's around 8 Hertz. This bandpass filter will take care of it. So we have bandpass filter between 10 and 500 Hertz. So if normal ECG will get filtered out, okay? What I tried in my experiment, I set the high pass filter to 0.7 Hertz, okay? And still I could not get ECG in. That's why I don't have a sample of signals here. Okay, how to eliminate it? Or at least try to. Try warming up the electrode. First thing you want to do, rub the electrode from the outside. When you have elastic band over the electrode, just rubbing it with your hand will produce a lot of heat. Heat will kind of melt the paste inside, kind of make better conducted with skin, maybe a bit moist the skin, maybe a bit, okay? And this usually helps in 80% of cases, okay? Just rub it, heat it up, it will be better. The next step, remove it, do additional skin cleaning, reapply it. You can use, of course, the same electrode as before, if the paste came out of the holes, so reuse it. If not, apply a new one, prepare a new one, apply a new one. Check if electrode is strongly bent. This usually happens due to too strong taping or because of muscle activity. And the last thing, we cannot do anything about it, okay? This can happen on kind of sporty people, okay? We have done a lot of recordings in last time on the tibialis anterior, and some persons have very prominent muscle when they do a dorsiflexion. And actually what happens is that electrode on the edges just removes itself, and you cannot do anything about it, okay? It is as it is. Check the reference. If they are in good contact. References can be tricky with the skinny participant. If they have very prominent ankle bones, very prominent tendons, the strap actually gets in kind of only point contact with skin. Check if they are in contact and check if any of the muscle is on muscle active, any reference is on muscle active area. Other devices used in measurement can cause a lot of noise. How to eliminate it? Just try to, I don't know, maybe electrical stimulator is the cause. Try removing the electrical stimulator electrode and see if it helps. Usually we cannot solve this. We have to use some additional devices. Isolate other devices. Try to put them on some rubber mats, whatever, plastic. Just try to isolate them. Check the environment. So check if the participant is in contact with metal. If participant maybe wears smartwatch or has a mobile phone in pocket. This can be tricky. Phones and smartwatches usually don't produce noise if they are in calm state, okay? But when new message received, the vibration, vibro inside the, I don't know, smartwatch phone turns on, and that can cause noise, okay? And it's like, not, of course, always present, just at certain moments, and you can have hard time identifying it. Last thing, which I would not advise doing, but you can, is quick frequency analysis. You have to know what to look for, okay? Here I did a quick fast Fourier transformation. What can we observe here is that we have 50 Hertz all over, okay? The two electrodes that have noise in the frequency domain as well. As I talked before, I did this when we had the problem with MRI machine. I saw that there was a lot of noise around 400 Hertz, but it did not help me at all because I could not identify what it is. Okay, so you have to know what to look for if you are doing frequency analysis. This is one of our attempts to get rid of noise from electrical stimulator. Can you see this? This is stimulator electrode. What we tried doing was wrap it in aluminum foil. It did not help. Okay? We had a lot of line interference, and the cause of line interference in this case was that we had a dead battery in Quattrocento, and we did acquisition directly from the AC, and did not work. Solution: get your battery replaced, and everything works perfectly. Okay? Okay, the most common steps when unexplained noise is present. Lightly touch the electrode from backside. This will immediately cause 50 Hertz to appeal, and it's a quick check if system even works. Okay? Check if references are okay. Try heating up the electrode. Try heating up the electrode a bit more. Okay? These two steps usually solve the problem. Remove the electrode, do additional skin cleaning, reattach the electrode, repeat electrode heating, or at the end, just replace it and try again. Okay, what about when none of the attempts work? Okay, these steps are quite important, at least first two. The most important, stay calm, okay? The next one, take a deep breath. The third one usually works for me, so blame coworker for poor electrode preparation. If I prepare the electrode, I blame usually Nina that he prepared skin. Okay, so she didn't do skin cleaning as she should. Okay, this is sometimes quite hard to do, but yeah, it can work. Remember today's presentation and our scientifically proven theory, which says unalignment of Jupiter moons can significantly affect surface EMG acquisition. Okay? This is quite possible. Pray to the EMG acquisition gods. Okay. Have tried, did not work. And the last one, tell your boss you did everything in your power, even waited for moons to realign. And that the problem is in equipment and that he has to buy a new amplifier. And what usually happens after the last step, when you do that, signals miraculously become perfect. Boss usually doesn't want to give you money. Or, more likely outcome, he will force you to do all the steps again. But after you do it perfectly, you get something like that. Okay? Happy boss, happy life. Okay? The last step What to do with electrode after use? Clean it with some isopropyl alcohol, rinse it with water, dry it up, store it for later use. After the next use, be sure to check the electrode for oxidation. If there is any oxidation, try removing it or discard the electrode and use a new one. Okay? The last thing, I will do some practical demos during the poster session. If there's any interest, we can meet, find me, look for the Quattrocento and I'll be there, okay? And we can talk, we can try something out if you have any questions regarding that. Thank you. And any questions, and then okay?